Okay. Test. Yeah, that's working. For anyone who's just showing up, we've just started early, so just to make sure everything's working properly. For anyone that's joining, we won't start until a little bit after 7:30. Okay. Okay, we got a few people saying they're just coming through from Facebook now. Which is good. We will just wait for some people to show up in the chat before we start. Hello. Thank you very much for joining. Who have I got from Reservoir Aquatics? You're the first, by the way. Welcome. Paul. Okay, Paul. Thought it might have been. How has the last couple of weeks been for you since all the fuel stuff going on, Paul? You noticing all the fuel surcharge hikes and everything as much as I am? Well, I mean, not to put doom and gloom on it or anything, but because I deal with a lot of bulk carriers, so large pallet loads and things like that, we regularly get updates. So for anyone that doesn't know, bulk carriers, they charge a pallet rate plus fuel surcharge plus GST, because the fuel goes up and down, so they charge the fuel surcharge separately, and they update that usually monthly to bi-monthly. Within the last month, I've got no less than 3 or 4 updates from multiple different freight carriers that's gone from 22%, which it was before, up to maybe 35%, and the lowest I'm seeing at the moment is 48%. It's getting up to 53% and 55%. So, and that means that everything that goes on a bulk carrier, so food, livestock, bulk items, essentially everything that goes from the dock to the central depot, it's all getting charged an excess fuel surcharge. So it won't be long until normal freight prices start going up as well. Yeah, it's a bit of a topsy-turvy kind of world we live in at the moment. So we have 4 people in the chat. Hello, everyone. I don't know who you are. I can't see your names unless you comment in the chat. So feel free to talk, ask questions. We're not going to start for probably another 2 or 3 minutes. Yeah, by all means, this is just we're chatting at the moment, and we'll just give everyone a chance to sort of, get themselves in line and get the kids sorted out or dinner or whatever. Give everyone a chance to get here so that we don't jump in, because yeah, I've got the itinerary here, and as you can see, it's about 9 pages of notes. So, yeah, excuse the cough. I can't. Overnight, because the temperature's been dropping, we're getting 5 degrees overnight here. I had to bring all the fish inside from outside. I was actually starting to lose a few. So, hello, Zoe and Anya. How are you? Not washing your hair. I'm happy to see. Yeah, so we get really cold as soon as the sun goes down. Everything gets really cold here at Inverell. The days are still beautiful at 25, 26 degrees, but nighttime it just drops, and when that does, my cough starts playing up. I just have to stop smoking filthy cigarettes is the problem. But yeah. Yeah, anyway. Thank you very much for coming along, Anya and Zoe. Very good to see you guys here. No, you're right, Paul. It hasn't affected the small package area too much yet. Mostly because I think it would be such a huge job and not very well received, I don't think, by customers, for them to do another rate hike like they did at COVID. So, yeah, let's hope they hold off. Everyone's staying home now because they can't afford to go anywhere, so everyone's shopping online. So it's not like they haven't got business. So, yeah. Does everyone have cups of tea, beverages, beers, scotch if that's your thing, bourbon, Coke, whatever the concoction is that Zoe used to drink on the live streams back in the day? I'm not sure what it was. I think Pimm's was involved. Oh yes, Anya, definitely it will be available here on my channel. Yes, all live streams get recorded and then uploaded. So yeah, that will be that it will be available. Yes, no doubt. Oh god, so he's drinking tequila. Not oh god. If you can ever imagine the most polite English person that you've ever met, but slightly tipsy. It's always a good time for Fragger Armor and a conference, Zoe, obviously. Yeah, as long as you don't steal my hat too much. Because as you can see, I'm getting fairly thin on top. That's why I've got to grow it all down here, because I haven't got much up here going at the moment. Just holding on to as much as I can while I've got it, essentially. Vodka and lemon, very good. I hope you're mixing that with water or soda water, because sugar is the other white powder. Yeah, not good for you. As I say, drinking tea with 2 sugars in it, but Hello. How you going? Good, thanks. Yes, so we've got 6 people in the chat. I'm sure more people will come along shortly. It's 7:35, so we'll just start with the introductions, obviously, about what this live stream is about. No one's really going to miss out on that. There's nothing to do with the information afterwards, so if they're not here yet, they're not going to miss out on much over the next couple of minutes. So, where's the salt? I was contemplating a couple of months ago the fact that usually these days when I walk through an aquarium store, I don't even see aquarium salt really on the shelf. And I don't know how long it's been since any of you guys that might work in a retail store have gone, okay, have you got your, whatever your spiel is, your food, your water conditioner, your aquarium salt. Have you got aquarium salt? Because I mean, you know, they go through that quickly because they're using it at 0.5 gram per liter, 1 gram per liter, whatever, and it's cheap, right? So, how long is it? I mean, not even considering sodium chloride, which is just normal aquarium salt. I don't know how long it's been even before that I even saw water conditioning salts on the shelf. They used to be everywhere. You know, what sort of fish you know, for your general people, like people keeping cichlids or hey Badge, how you going? Good to see you here, Jules. Thank you very much for coming along, mate. This that is Badger is Julian from Triton. Triton Applied Breed Biosciences, who we will be talking about later on when we talk about TDS and conductivity and general hardness and what contributes to what and how to test what and how to differentiate and all that kind of thing. And it's not simple. So, yeah, we'll get into that. Where was I? Yes, haven't seen salts, haven't seen conditioning salt blends on the shelf. I mean, people that keep roof lake cichlids, they know they need to add it, or they add, you know, aragonite or coral rubble to their aquariums. But, you know, whenever I used to sell live bearers, you know, you sell salts and minerals with them. You know, it's not going to be for everyone. Other people will keep different tanks and they will supplement different ways. You know, to think about something here, when you see a aquascaped tank, you know, people that are really into their aquascaping, and you see the beautiful lush growth and it's green as a shamrock, like it is green. You know, beautiful planted tanks, and you always notice that the fish are massively fat and healthy and colorful, and they're breeding, you know, and they're just like, they're not. The reason is because plant keepers that are at that level of aquascaping and plant keeping are actively adding different sorts of buffers, such as potassium hydroxide is a very common liquid supplement. I think the ADA version is K Power or something like that. It's the buffer that you add, but it's potassium based. It's potassium hydroxide, I think, or a potassium buffer of some description. But yeah, they're adding potassium, they're adding calcium and magnesium because they know their plants need it. They're adding trace elements, they're adding root tabs, which are getting remineralized and put back into the system. They're adding a huge different range of minerals just without even thinking about it, because that's what's in their, you know, nutrients or fertilizers or buffers or whatever it is. And most of the time, these plant systems that people follow before they start to, you know, make their own, right? Before they then understand the chemistry, and then they're right anyway. But before that, most of these ranges will have the right levels of NPK, calcium, sulfur, sulfate, chloride, everything in it. And it's getting dosed constantly. So no wonder the fish don't have deficiencies, and no wonder they're happy because they're getting everything they need. But, you know, put plants in your tank, and even if you keep African cichlids, you know, you throw coral rubble in the bottom, that is just calcium carbonate. By the end of it, most of that coral rubble is just calcium carbonate. You know, you do get some magnesium and things like that in it, but, you know, this is the reason why in calcium reactors you always have to put a magnesium carbonate of some description in there if you wanted to do magnesium as well, because aragonite just doesn't have a lot in it. And it's got to acidify before it'll dissolve. So it's got to be in a low pH environment with bacteria that are breaking it down so that that calcium and carbonate can be liberated into the system. But again, it's only calcium and carbonate. You haven't got magnesium, potassium, carbonates, hydroxides. You know, you look at Riff Lake chemistry analytics, and yeah, so it's not the same. Oh, Paulie, wonderful to see you here. Wonderful to see you here. I know you would sell a lot of salts because I know you know exactly what I'm going to be talking about here. Paul probably is one of the biggest proponents for water chemistry, especially in the way of GH and alkalinity. Yeah, I'm not surprised that he's still selling salts and minerals, because he and his team do have the fish's, you know, well-being at mind. And they like to see their customers succeed. And the way they succeed is to, you don't want to have to, you can watch this stream and you can take it and learn from it and look for it yourself. But are you going to be able to explain everything that I'm going to explain in this live stream to a customer right away? No. And it'll go, whoo, it'll go straight over their head. It'll be like getting slapped in the face with a bag full of dead fish to them. It'll be just, it's. So what do? Well, you've got a salt mix that's got generally everything you need in it, and fish adapt, and you've got community fish anyway, so you got a variety in there. And I use it in my tanks here in the store and have done since day dot or whatever. You don't have to explain much. You just say it's just got the salts and the minerals in it that they need. Like we need salt and calcium and things, they need that too. It's an easy way to explain it to people, and it takes out the guesswork because, as we will find out, each river system itself has, a slightly different water chemistry. And then you've got alpine regions or very, clear sweetwater regions that don't have a lot of dissolved minerals in them at all. But the only reason the fish survive is because they've got constant flow of very clean fresh water. It's not a closed environment where you need biofiltration or anything like that. So, pH, KH, and GH testing is significant. Yeah, well, it has. Yes. And pH and KH and GH are interlinked, especially when we're going to talk about conductivity here in a minute, because different ions have different charges, and they contribute to general hardness, alkalinity, and conductivity. Some ways by themselves, some ways together, some ways interlinked, and some ways not. And we'll find we'll find out about that as we go along in the stream. Paul, this is the other thing. The systems that have been developed for plants, because plant requirements for nutrients and things like that are very well known. Very well known. Agriculture is a industry that dwarfs the aquatic industry. But you thought that the pool industry dwarfed the aquatic industry? Agriculture, just fish farmers, who were they? Plants, whether terrestrial or aquatic, have, they have very, very well documented needs. And that allows manufacturers to put together very, very, very effective fertilizer programs and things like that, and simplify it so that they're getting everything they need. So by proxy, just by accident, for lack of a better description, the aquascapers that are putting everything together and they're doing their water changes and stuff, they're also putting the fertilizers in. And although they may not know the interaction between calcium and magnesium and temporary hardness versus permanent hardness, and that's also called GH and KH, and the plant system allows them to streamline that and takes care of it for them. So, and in a busy world, that's sort of what everyone looks for, I suppose. Yes, and this is exactly why, as I was explaining, as to why I'm putting this together, because GH is a very, very, very important parameter, and there's a lot of stuff that people get confused, and there's a lot of stuff that's unknown about it, and this is going to be information heavy because it needs to be. So we will dive right in. So generally speaking, you find that general hardness test kits will test just calcium and magnesium. And the general hardness test kit is probably the easiest way to start. What it does and what it's measuring. It's just measuring calcium and magnesium. Okay? It's just measuring that. Now, excuse me. Now, what's also mixed in with that test is a indicator. All right, so there's two different parts. You've got the indicator that's in there that changes in the presence of calcium magnesium ions its color, right? The titrated reagent that you've got is usually some sort of EDTA, and it's precipitating out the calcium and the magnesium. Now, per drop, that precipitation is known as a calculation. So when the calcium magnesium is all precipitated and bound up by that EDTA, that reagent that you're dropping in, and you're counting the drops, When that happens, it drops all the calcium and magnesium out, and therefore the indicator is not indicating that there's any calcium and magnesium in there anymore because it's all been bound up and precipitated, right? And then you take that number of drops, usually if it's measuring in German degrees of hardness or DGH, 17.9. So you multiply each drop by 17.9, and that gives you the parts per million. Now, I don't like the German degrees of hardness because it's 17.9 per point. So it could be 0 or 17.9, or it could be 17.9 and whatever 17.9 and 17.9. It could be anywhere in between that, right? Normal test kits these days test in 5 or 10 part per million increments. The good ones test with syringes, so they test in 1 part per million increments. But you're only getting calcium and magnesium. Now, general hardness as an indicator, yes, that is good. But what about the rest of it? So the big three. So now that we know how a general hardness test kit works, right? The big three or four, we'll say, are calcium, magnesium, potassium, and sodium. Calcium for obvious reasons. They get the water. They get the water out of the calcium. They get the calcium out of the water. They draw it out of the water through their gills. And they also get it from dietary forms and things like that as well. And this is used for bone and scale structure. It also is involved very heavily in muscular contraction and muscle health and things like that. You can get deficiencies very easily in it. So it's a good idea to keep calcium levels a little bit elevated. As I said, I have 9 pages of notes. So if I look like I just don't want to forget anything. I don't want to forget to mention anything. So if you see me glancing down, I'm just trying to figure out if I've covered everything. Okay, so yes, involved for the heart, blood clotting, and enzyme activation. Okay, so along with magnesium is involved in hundreds of enzymatic productions, and we'll go into enzymatic reactions, and we'll go into that. But calcium is also involved. The fish can absorb the calcium directly from the water through their gills and their skin. So freshwater fish are constantly getting bombarded by water. And we'll go into the differences between freshwater and saltwater fish, how much water they drink, how they get the salts and minerals out, etc., later on. It's obviously, yeah, dietary calcium is less critical in hard water because they can get it from the environment. But in soft water conditions, you have to make sure that you can get dietary calcium into your fish. Big problem with soft water fish. But conversely, with really sensitive fish and discus that haven't been bred in increasingly hard water, although they might like a little bit of hard water, the eggs will harden before they can fertilize. Same with angelfish. So again, dietary calcium, make sure you got it in because you don't have a lot of it in the water. It's good to have some, and especially if you got plants, you're dosing calcium all the time anyway. But yeah. Soft water, more important. Hard water, less important. Dietary calcium, make sure it's in there. But here's the kicker. Excess calcium in the diet can precipitate phosphate, and that's how kalkwasser works in marine aquariums. The calcium and the hydroxide ions bind the phosphate, and that's how kalkwasser or calcium hydroxide binds phosphate out of the water. So it will also precipitate, I've got a list here, zinc, iron, and manganese as well. So, don't go too heavy on the calcium or you might give your fish kidney stones. I haven't ever had kidney stones, but I hear they are not fun. I'll just check the... yes, what if people don't swirl enough? Exactly. That's exactly right. But, what's a little swirl to you, that, test tube is moving a fair amount of distance. So you just got to... Personally, I really like the Red Sea test kit setup with the syringe titrator and the thing that you put on your hand and you screw it onto the top, because you just pour it and then you just and you can do it while you're pressing on the syringe. I reckon every test kit should have that design. I'm not talking about the reagents. I'm just talking about the test tube and the test tube holder and the syringe. I reckon every test kit should be measured in parts per million, because metric is king, and America, we're waiting for you. The world is waiting for you to catch up. But yeah, parts per million, because it's the metric system and the little system. I love them. I love them. I just, yeah. Anyway, I'll stop fangirling about that for the moment. What do people don't swirl enough? Now, nitrate test kits, just going off on a tangent, nitrate test kits, especially the API test kit, has anyone ever read the instructions? When's the last time that you read an API nitrate test kit or any nitrate test kit instruction? Because, and it's going to speak sacrilege here, but API test kits are actually very reliable for what they produce. For general testing, you really can't beat them. They're turned over a lot. The reagents are fresh. They've had long enough and sold enough of them to get the formulation right. Very rarely problems with them. That's aside from the point, though. Nitrate reagent 2, especially in the API test, and it says in the instructions that you need to shake it for 30 seconds at least before you use it, because there's two or more separate things in there. They have different viscosities and they settle out if it's left to sit. So what happens is, if you turn it upside down, viscosity, oil and water, for instance, one floats on top of the other, you'll get a less concentration of one reagent and more of another. And as you get further on, your test kit tests more and more inaccurately. Read the instructions. Shake your reagent bottles. I shake every reagent bottle. I don't care what it is. Or use a spin touch. That solves the issue too. Then you don't have to worry about shaking test tubes or worry about human error. It's just bang, 2 minutes later you get your results. And use the timer. Yes, use the timer or your phone timer, and you can just set a different name for it. I just tell Siri what to do. Set a 5-minute ammonia timer or a 5-minute nitrite timer, 5-minute nitrate timer. If she gets it right, that is, and labels it correctly, and I don't get confused. But yes, anyway, moving on. Life is much easier with a spin touch, Paulie. Yes, it is, very much so. But that's for another time. Okay. So now that we've covered calcium and magnesium, the other part of general hardness that we're going to be testing with the general hardness test kit. Now, general hardness test kits still don't tell you how much calcium and magnesium is in the water. And none of these tests will, even conductivity and TDS and salinity, none of them will, apart from an ICP test. But this is everything else that you get to then get an ICP test to work out what your baseline is. But we'll go into that a little bit later on. So magnesium, the other part of a general hardness test kit, and the other part of what is termed general hardness in aquarium and aquaculture, aquatic industries. So, as I said, it is the cofactor for over 300 different enzymatic reactions. The energy metabolism, the ATP magnesium complex, and ATP stands for, and I'm going to read it off another screen because I can't pronounce it and I forget how to pronounce it, adenosine triphosphate. It's the primary mover and energy carrier for all aquatic life, all life, actually. Plants, fish, humans, bacteria, everything. ATP. Adenosine triphosphate. I'll remember it one day. Too much to remember. Adenosine triphosphate. So this is on a mitochondrial level. And it works to exchange salts and minerals and then energy throughout the mitochondrial cells through the body. So in any living organism, the ATP molecule can be recycled like 20 to 30 times before it's depleted. Okay, this works in conjunction with mitochondria. With fish, one side it works directly at is the water-to-gill interface, which we'll go into in a minute, and is very important when adding salt, actually, because there's more than one interaction. So the ATP-MG or magnesium complex is the biologically active form of ATP. It helps with protein synthesis, carbohydrate metabolism, neuromuscular function, and bone formation. Now, that's interesting, the bone formation one now, because you know that the thing that stops calcium carbonate precipitation in seawater is magnesium. It is the ham that goes in the sandwich that stops it from all going soggy. right? Otherwise, without magnesium, calcium and carbonate would just precipitate as calcium carbonate, which is what corals do. And they grab magnesium and strontium and all the other things. So bone formation, magnesium, very important. It's part of bone formation. It is part of calcification. So magnesium deficiencies are a little bit harder to spot, and they can be recognized as other things as well. Okay, so things like anorexia or loss of appetite, you could mistake that for an internal parasitic infection. You could mistake that for old age. You could mistake that for a change in food. Okay, but it's sometimes on a mineral level dissolved in your water that you can't see. Okay, sluggishness, skeletal deformities in fry and juveniles, reduced growth, and under autopsy, there can be damage to the kidneys and things like that, such as calcification on the kidneys with calcium carbonate dropping out and precipitating and depositing on the kidneys. So that can be it. And in plants, there's other deficiencies that are here. People that are better with plants, that are much more knowledgeable than me, will be able to tell you all about that. I'm not going to go into plants, but we all know plants need magnesium. So the problem is with magnesium is magnesium deficiency is much worse than calcium deficiency because fish can't absorb as much magnesium from the water as they can calcium. So dietary magnesium is important, and that's why you have to have an elevated level of magnesium to be able to compensate for that, or a regular addition of magnesium to make sure that your fish aren't deficient in that. It's easy though. Magnesium sulfate, Epsom salts. Now, I might add, while we're talking about other forms and ways to get a hold of individual chemicals, Anya asked a question with her customer with a very large pond that can they use pool salt in their goldfish pond? Right? Now, whenever you buy bulk salt, you will buy it from one of maybe 2 or 3 suppliers in Australia. They are Cheatham, Elson's, I think, or something else. They have various different sources of sodium chloride. Some of them are cheaper. Olson's, that's what it is. Not Elson's, Olson's. Some of them are dirtier than others. Some of them come from inland saline sources versus solar evaporated seawater. Cheatham salt predominantly evaporates seawater on the Gold Coast, straight off the Great Barrier Reef. So it is a very clean salt. You will buy various different grades of that when you buy salt. So flossy salt, for example, used in cooking and cooking salt and stuff. This all comes in 25 kilo bags to bakers and stuff like that. And this exact same salt is just rebagged for these pool companies in their own bag. It's the same salt. So yes, you can use it if you wanted to get 25 kilos of sodium chloride and store it and pay for that. I mean, it's not expensive. But I would recommend that if you are buying it, try and buy Cheatham salt, Mermaid, or a rebranded Cheatham salt, because it's all pretty good. And to set your mind at ease, I actually have a bag of Cheatham salt downstairs that I use to dose all my ponds with outside, and have done over the summer. I put them all inside now because they're all dying because it's so cold. Not all dying, but some of them are starting to drop off. But yes, I use sodium chloride. So yeah. But yes, so you can, pool shops, obviously they don't know about this, and it's just, oh, you're putting it with, I don't want to kill your fish. But, there's precautions you need to take. Cheatham salt, good quality. Try and get the Cheatham branded Mermaid salt. Oh no, magnesium salts, don't go getting that. Magnesium salt, it's either magnesium, I think it's magnesium chloride actually, that's why it's so expensive, and it's just, they use it in the saltwater chlorinators the same way that the sodium is, because it's the chloride is broken off the sodium as you add it to the pool, and turned into chlorine to chlorinate your pool. Same with magnesium, but the magnesium is more soothing on your skin. It's really good for people with dermatological problems, as is hydrogen peroxide or ozone as well. They usually use those two in conjunction, and you'll find a lot of therapy pools use magnesium salts, but do not go like willy-nilly just adding straight magnesium. Sodium chloride, yeah, and if you tell her, like, if she's got a 1,000-litre pond, 1 gram per litre, or a kilo of salt in 1,000 litres, yeah. Goldfish can go up high. Goldfish will be quite happy at 4 or 5, easily, even fancy goldfish. Long term, for their entire life. Same as silver perch, barramundi, a lot of aquaculture species, very common because, in aquaculture, we're taking the biofilters to the limit. So nitrite, slightly elevated levels of nitrite, or what we call residuals in aquaculture. So residual ammonia, residual nitrite. So don't be shocked, people in the aquarium industry, but it is quite common to run an aquaculture system at anywhere between 0.25 and 1.5 parts per million of ammonia with massive, fish, with adult fish. Broodstock and juveniles obviously lower, because we want them to be as healthy as, we're feeding broodstock a champagne diet of shrimp and prawns, and they eat better than I do, in most cases. All cases, actually. But 4,000 was the estimate, so 4 kilos. 2 kilos to go half a gram per litre, 4 kilos to go a gram per litre. And if she's never added salt before and she's got plants in there, just go slow. Aquatic plants will handle quite happily 1.5 to 2 parts per thousand, the majority of them. I mean, I'm not saying, go and throw all that salt in with your really expensive plants. Read the room. And, with any of these applications, I'm not just saying go and buy Epsom salts and go and buy calcium chloride and potassium and start dosing willy-nilly. You got to know what you're adding, why you're adding it, and you got to be able to measure it too. So, and this is what this stream's for. So, but no, don't go buy magnesium salts under any circumstance. You only need magnesium, like Epsom salts from the supermarket. Better yet, if you don't want to bugger around with all those things, go down to your local aquarium store and ask for some salt mixes. Seachem have a wonderful range of different salt mixes for tangernicans and reef lake and guppies, like live bearers, goldfish, And Seachem's really affordable in Australia now, like compared to other stuff. That's just one. I mean, obviously, I used to work at Aquasonic. That's where I started my career. So the Aquasonic conditioning salts and stuff ended up at Nature's. But I'm not offering, anyone preference here with brands. I'm just mentioning things that are out there. Okay. So Aquasonic, and I mean, I used to, when I worked at Aquasonic, I worked in the office, and 50 meters down in the shed was where they used to mix the Ocean Nature sea salt and all the water conditioners and everything. I even got to see the guys in the lab, weighing out the individual, and they've got little spoons on little jeweler's scales, right? And they're weighing out 0.17 of a gram for 100 kilo mix or something like that. I'm being ridiculous, but small amounts. So yeah, go and buy a conditioning salt mix. It'll cover 99% of the bases. And unless you're trying to breed fish and you've got, really, really, sensitive fish or anything like that, generally speaking, 99% of the time, you'll be fine with that. Olsen salt, there you go. Yep. Olsen. But yes, you're right. Not all plants can tolerate sodium. And that's why I said, do your research. Don't go adding sodium chloride to fish or plants that can't tolerate it. Like I said, with alpine species and soft water species and high altitude species where you have snow melt or rivers where you have no mineral composition whatsoever, like a very andesol-like soils and things like that, they're very humus rich, right? You're not gonna, if you have plants from that area or they're sensitive and things like that, obviously, if you're keeping sensitive plants and sensitive fish, what you're doing, or if you've been sold them, hopefully not mistakenly. So it's horses for courses, but yeah, it's with a grain of salt, so to speak. So another interesting thing that I have used, Val is sensitive to sodium. That is one thing that I have not found, to be honest with you. The Val from, well, actually, I collected it from around here, so considering it's from Inverell and it's I don't know. That's interesting information, though. I did not know that. That might be why some of my ponds do better with Val and some of them don't, because the top pond I don't really add sodium to, I don't really add salt to, and that Val goes fine. And then some of the ponds downstairs that I do add salt to, so that would make sense. There you go. I've learned something today. Thank you very much, Paul. Magnesium sulfate. Or magnesium in general. Now, I have used with great success magnesium sulfate to treat hexamita in angelfish and discus. Throwing Epsom salts into the water, soaking the food in a solution of Epsom salts, and then, because we used to mix up all the frozen foods and stuff, and then put some enrichment in. We used to use a variety of enrichments. If you're looking for a food enrichment, I've got the Enrich UM, now that Celcon isn't available anymore. And that's my brand of enrichment. So if you were looking for a live food enrichment or a food soak of any description, the Enrich UM is a really good option. But we used to mix all that together. A little bit of garlic sometimes, blah, blah, blah. If we were treating with Metro as well, we would treat separately with food. But generally speaking, it wasn't required if we caught it early enough with magnesium. And you'd actually see the fish start to purge it out, and then they got better. Obviously, then the next step is Metro. But interestingly enough, the magnesium has a scouring effect on the inside of the animal. It has a paralyzing effect on the parasite, so that it is easier to detach. And then with the exfoliation and the higher salinity, they tend to, detach a bit more, as well as being paralyzed somewhat by magnesium, because you can actually anesthetize fish if you add enough magnesium to the water. It'll slow them right. It won't knock them out, but it'll slow them right down. And it has a laxative effect, so it purges them. So as well as the parasites getting weakened, and also relaxing, and getting attacked by an increased salinity, it just causes them to flush it out. It's very effective. So that's usually about a 3% solution, 3% of your food volume, but we'll go into that a little bit later on. Okay, potassium. This is the big one, because no one doses really potassium, and potassium is, and I have always said, one of the most important ions, especially in freshwater. So it is the primary ion for osmoregulation. It's the pump. It moves everything. In plants, in fish, it helps to move everything. It is used for intracellular ion balance. What that means is it is directly involved in osmoregulation of the cells right through to the blood, through to the outside of the fish, and in and out of its gills and everywhere. If you're lacking in potassium, even if you've got other stuff in there, adding potassium is going to make things a shitload easier for you. Okay, so the metabolic functions. Okay, apart from osmoregulation and intracellular ion balance, it is heavily involved in nerve impulse transmission, so nerve firing, right? And the acid-base balance of the blood, so the pH level of the blood and the internal acid-base balance of the fish. Now, you can imagine that if you're working harder to osmoregulate and you don't have the chemicals, and then you're getting an imbalance because you still don't have the chemicals, your body's just working overtime, man. It's just really not having a great time. It maintains cell membrane potential, and that means that it makes the cell membrane tough. Does the same thing have you ever heard of when you have plants like tomato plants and stuff, to harden them up? Use potassium or potash, harden them up, hardens up the cell walls, makes them lignify. Same thing. It regulates heart rhythm. Now, have you ever heard of elevated potassium levels in heart patients? Too much potassium will send a heart patient over the limit, give you a heart attack. Same thing happened to my old dog, my old Alaskan Malamute. She had Addison's disease, which is an inability for her renal system to function properly. And she used to go and have all of her internal electrolyte balance tested monthly, and liver enzyme and all that kind of thing. And potassium was the main one, because as soon as the potassium levels got out of whack, she'd go flat, her heart would start, it's all interconnected. Potassium's important, is what I'm saying. It activates enzymes for protein synthesis and photosynthesis. Potassium is incredibly important, and usually with the majority of plant deficiencies, especially terrestrial plant deficiencies like vegetables and things like that, it's usually potassium. If you have an excess of potassium, you generally don't have any other problems, because as long as your soil's alive and remineralizing nutrients, the potassium allows everything else to move a lot easier, along with calcium. Potassium and calcium are very closely linked. Again, deficiencies, and there's lists. So anorexia, reduced growth, again, that can be mistaken for a variety of other ailments. Darkened body coloration, but depends on the fish. Muscle spasms, I don't know how you're going to see that in a fish. I mean, you might be on really good first name basis with your fish, and talk to them about that, and cramps and stuff that they're having, but generally speaking, I haven't had that experience. And mortality at extreme levels through lack of potassium, but my God, you'd catch it before then and do a water change. Yeah. So, as I said, potassium is the primary intracellular ion. It makes everything else move. Sodium is extracellular, so it doesn't get actively pumped. But the Na and potassium, the sodium and potassium relationship, is the primary fundamental mechanism of osmoregulation through ATP in fish gills. So your sodium and potassium move together. The potassium moves with the sodium, helps it along its way, which helps ATP production and regulation, which then helps osmoregulation and the movement of salts and minerals in and out of the cells of the body of the fish. So potassium deficiency in plants, I've got some notes here. Pinholes in the leaves, yellowing between the veins. My tomato plants are suffering from that exact thing at the moment. Stunted growth, again, yes. So both fish and plants need it, and microbes. Now, a special mention to microbes for Gregory, who asked a question, Gregory Walker. This is exactly the concept behind OCK and my product OCK. It has a metalloenzyme complex. So along with the organic sources of organic carbon and energy, are several different metallic ions that are in that mix. So calcium, potassium, magnesium, zinc, copper, iron, a whole range of different stuff. Now, that is required on an enzyme basis for bacteria, right? So not so much metabolism. So when we're talking about ATP production and the movement of ammonia and nitrite throughout the nitrogen cycle, you've got the nitrifying bacteria. They need carbonates or bicarbonates. They need the ammonia or the nitrite, and they need oxygen. And what they spit out, if they eat ammonia, they spit out nitrite, carbon dioxide, and water. They eat the carbonate. It's like if our blood doesn't have enough iron, it won't carry very much oxygen. This is why vegans are always tired, because they don't have enough iron, right? It's true. This is why vegans need to take iron supplements, right? It's exactly the same concept. That's not a dig at vegans. It's just an example, right? Involved in enzymatic processes. So if we don't have potassium, then the other additions of sodium and calcium and magnesium and things like that are harder to move throughout the metabolic pathways throughout the fish. There's actually been multiple studies done where elevated levels of potassium have actually increased growth very significantly in aquaculture species. And you will find that elevated potassium levels in marine systems is also quite beneficial, especially for blue coloration. And I will add, bicarbonate and carbonate forms of potassium are actually, in my opinion, better at stabilizing pH and alkalinity than sodium or calcium based bicarbonate or carbonate ions. It lasts for a lot longer. It results in a slightly higher pH for the same KH. It has a slightly higher pKa rating. It's just better. I like it better. Okay, so moving on. So the interconnection between these three, they work together. You can't just fix one in isolation. You need to know. You need to know what you're adding. This is why ICP tests exist. This is why Isan invented ICP testing with Triton. Okay. I don't know how many of my aquaculture customers use Triton ICP testing as a base form to work out what their source water is so that they can then supplement, which is what needs to happen. That's the echelon. And you're not going to get ICP tests done all the time. Again, Triton will even tell you ICP tests are done for to track stability. And then you use your testing at home to do that and then alter as needed so that then you can adjust your maintenance schedule. But I'm not telling you anything that you don't already know. The ATP pump that works with sodium and potassium won't work very well if you have one or the other. You need both. It needs both to function effectively. So if you have a deficiency in one, you're going to notice a deficiency in the other. That goes right down to bacteria. Okay, so again, with your nitrifying bacteria, while they will need ammonium nitrite, blah, 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 coming back to that point, you would, while they need, that's what they eat, okay? And then they need other nutrients, just like heterotrophic organisms like us need all different sorts of minerals and everything like that. But we eat food, right? But we get the nutrients from it. They eat ammonia, but they get nutrients from the water because they have very, thin cell walls and things like that they can, get it through diffusion. And that's one of the reasons why elevating or dropping salt levels works so well for bacterial and parasitic infections as well. So, as we know, calcium affects magnesium absorption, and magnesium affects the enzyme function, and that requires potassium. So all three of them are linked. So you need to be adding them in one way or another, dietary or otherwise. Now, fish's blood is at anywhere between 10 and 100 times elevated levels of what their urine is. And their urine is at lower levels again than the surrounding environment because they're sucking as much nutrient out through drinking as much water as they can, or drinking as little water as they can because they get bombarded with water through osmoregulation, through trying to force its way in through their gills and stuff, right? Because they're trying to get water out. That's what the stress with osmoregulation is. But by reducing that balance, by increasing salinity and decreasing the gradient between their blood and the water, it eases that. So right down to a bacterial level, it's just, macro and micronutrients versus what they're eating and things like that. It's very, very important. Each organism, each bacteria will require a different range, just like humans or animals. Or, for instance, pompano require an elevated level of taurine. Taurine is what you find in Red Bull. That's why they call it Red Bull. Taurine, bull, yeah. And they require an elevated level of taurine, but no other fish do. But that's just a dietary requirement, so they include it in the food. That's about it for magnesium and calcium and potassium and how they sort of interact together. Now, it's kind of going to look like I'm bouncing all over the place, but there is a reason to my madness of how I'm presenting this, okay? Because one thing sort of leads into another. So, generally speaking, osmoregulation is the mechanism at which fish control the balance of water and salts and minerals in and out of their body. In freshwater fish, it works one way. In saltwater fish, it works completely differently. And as I said, The difference between the salt and mineral concentration of the blood and the salt and mineral concentration of the surrounding water is generally higher, much higher in the blood, right? So if you're trying to work out what your fish roughly need, look at not only their bone composition, but also their blood composition. There's probably 1,000 different studies out there that go into that. And generally speaking, in freshwater fish, you'll generally find that it's, across the board fairly similar. So that's a good place to start. If you were looking for that information, that is. Freshwater fish are hyperosmotic. So their body fluids are much saltier. Like I said, they're much, much higher in salt and mineral concentration. So they're constantly fighting to keep that salt in. And they're trying to get as much salt as they can from their environment. So when they get all this water in, because it's hard for them to keep it out, right, the level of salt is much lower. It's very, very weak in salinity, their urine, and it's very dilute, and there's a lot of it because they have to drink a lot of water because the salts and mineral levels in the water are up. Well, they don't drink a lot of water, but the salts and mineral level in the water is physically a lot lower than it is in salt water. And the concentration gradient for osmosis is in the reverse. Okay. So, water's constantly flooding in through their gills, their skin, and their gut via osmosis. All right. So they don't drink any water, or almost none. They absorb the amount of water and the salts and minerals that they need through their skin and gills. So the fact that they're, getting all this water in and they're having to urinate so much to get so much water out, which is, very diluted in salts and minerals because their body's scavenging everything it can and storing it in the blood, right? Drinking more water would just mean that they would have really good kidney function, I suppose. Drinking more water would just exacerbate that problem. So we don't want to do that. Okay. Well, they don't want to do that, and that's why they don't. I mean, I'm sure I can't tell them what to do, but that's how the biology works. So copious amounts of dilute urine. We've been over that. That doesn't need to be gone over again. There is an active ion uptake at the site of the gills. So, as we were mentioning, on a mitochondrial level, in the gills, it's made up of special mitochondrial cells and mucous membranes and things like that that allow the transfer of salts and minerals across the membrane and into the blood. That's why the gills are red. And oxygen and everything else. It's all connected to ATP, oxygen, everything like that. So the gills actively pump in sodium and chloride from the surrounding water against the concentration gradient. Okay. So this is powered by the sodium and potassium ATP pump, right? So again, we need all of them for it to work effectively. Okay. It is the most energy intensive process in a freshwater fish's body. So if you can imagine, if we add a little bit of salt and a little bit of minerals to the water, we are going to reduce. So to make it simple, osmosis up here, freshwater fish down here. Okay. If you increase the salt level, you decrease this gradient. Okay, it's all working in reverse and I can't work it out, but you understand what I mean. It decreases the gradient, which decreases the stress on the fish. Decreases cortisol levels, decreases everything, right? Immune response doesn't get compromised as much because not as much cortisol is being produced and everyone's happy. Okay. Here's an interesting note. A freshwater fish may produce urine equivalent to 20 to 30% of its own body weight per day. Can you imagine having to go to the toilet that often? But yes, a massive energetic cost. 20 to 30% of the day, you're actively flushing liquid through your body. Or 20 to 30% of its body weight per day. That's even worse. Of its body weight per day. Jesus. Okay. Don't want to be freshwater fish. Now, saltwater fish in the reverse are hypoosmotic to their environment because the ocean is saltier than their blood. It works in reverse. Instead of the salt level being down here and the fish's blood salt level being here, the fish's blood salt level is here and the water salt level is up here. Right? It's working in reverse. So, water constantly leaves their body through the gills, through osmosis. Okay, that's very important. Through osmosis, through the gills, right? So the solution they have is they have to drink constantly to keep the amount of fresh water in to stop their internal cells from desiccating and being flooded with salt and essentially dying, right? That's how we get rid of pathogens, okay? Now, so they're constantly drinking large volumes of water, about 10 to 15% of their body weight per day, daily in seawater intake. Now, what they do, instead of producing a shitload of really dilute urine, they produce a very small amount of incredibly concentrated salty urine because they're trying to get all the water they can, all the H2O out, and then they need to get rid of all the salt because they've already got enough of that. There's too much in the water. They just want the water from it. It's like a biological RO unit, I suppose. So that's what they do. And they also have active salt excretion at the gill sites. The same chloride cells in the freshwater fish now work in reverse, and it pumps out excess calcium and chloride ions because, as well as producing very concentrated, very salty, small amounts of very concentrated, very salty urine, they still can't get rid of it, so they need to extract it from the gills. And it works in reverse through ATP. Very important, again. I've got a heap of stats here and numbers, but no one's interested in that. The next subject is the euryhaline fish. So fish that can go from freshwater to saltwater. So things like bull shark, salmon, sea mullet, Australian bass, tilapia. Tilapia can be cultured in full strength seawater. Mollies, right? They all have the ability to undergo a morphological change at the gill and hormone level. All right. So, and there's a lot involved in this. So, in freshwater, the hormone is prolactin, which reduces permeability and allows the uptake of ions. As we recall, we want to take up as much ions as that because there's so little in the water and they're drinking so much water. In saltwater, it's cortisol and a growth hormone to promote salt excretion. Okay, so they change depending on whether they're going from freshwater to saltwater. This changes at the gill level, and it can take anywhere between days and weeks. Right now, bull sharks I've seen go from at a fall site, I know goes from full strength estuarine water at about 20 to 25 parts per thousand to sweet water at 0. I've seen them go up over rapids. So there's no drama there. I've fed mollies to frontosa stonefish that we had in marine systems, and the stonefish didn't eat them, and it became their friend, and it lived in there for weeks, months. It'll live in there indefinitely. Mollies will breed in salt water. Freshwater, the Macrobrachium, Rohenbergii, or a lot of different other long-arm freshwater prawns, they have a saltwater saltwater growth phase, breeding and growth. They can change from saltwater to freshwater, but not as easily. Not all species can do it, or do it effectively. There are different tolerance levels. And different times it takes to acclimatize them. For instance, barramundi will go from full strength seawater to full strength freshwater within an hour. In some cases I've done it. At the hatchery, they go from saltwater to freshwater as they're going into the grow out systems. Sometimes they grow them out in salt water if they've got access to it. Sometimes they grow them out in fresh water. Morphologically, they change color, they change their gills change structure, their heads change slightly, their color changes completely. It's on a cellular level. I'm not going to be an expert in that side of it though, because I'm not. But why this matters for fish? Regulating the movement of salts and minerals and water in and out of their body is the biggest energy expense for fish. So by trying to reduce that, you're only helping your fish. This is why aquaculture systems, freshwater aquaculture systems, will be run at anywhere between 3 to 7 to 10 parts per thousand. Freshwater aquaculture species like yellowbelly, barramundi, cod reduces nitrite toxicity. When I was talking about those residuals, right, in the water, anywhere, you might have nitrite residuals of 0.5 to 0.75 to 1 part per million, and the chloride actually blocks the nitrite from being taken up in the gills as well. And it reduces the osmosis gradient, which allows them to grow faster and supplements, the ATP production and metabolism within the body and the cells and things like that as well. So even adding salt at 1 part per thousand reduces that osmotic gradient pretty bloody significantly. All right. So salt just as a tool to reduce stress is fantastic. And osmoregulation is different from disease treatment. And we're going to talk about that. Okay. So we talked about nitrite blocking. Everyone knows about that. Fairly common knowledge. No need to go into how that works or why that works, because we all know, and if we don't, then you can ask me later. So the way that salt works in treating disease is it stimulates the production of slime. It actually irritates the fish's gills and slime coat to get thicker, right? It's not actually therapeutic in a way for them, because the slime coat is their first line of defense, and it has all sorts of bactericides and hormones and all sorts of growth regulators and things like that in it as well. It's like a biological shield for the fish. Okay, so it simulates that on the epithelial of the gills as well, and sulfur parasites and things like that. This is why we give salmon freshwater baths in salt water, to get rid of amoebic gill disease in Tasmania. They have huge well boats where they pump all the fish out of the sea pen into fresh water, bathe them. The fresh water makes the amoeba that cause the amoebic gill disease to drop off, and they go back into the pen with no amoebas on their gills and able to breathe happily again. Working in reverse, obviously, in that way. So it just helps them to slough and shed crap, right? As well as, if they got open wounds and stuff like that, it's actually a barrier to, excess water getting in and things like that, and further stressing the fish out with osmotic damage, or osmotic stress, I should say. But salt you can add separately to calcium, magnesium, potassium as a therapeutic, depending on how much your fish need, want, or require at that period of time. So by reducing cortisol levels, obviously it can do really well in crowded systems for transport, a small level of salt. I know, for instance, aquaculture, they'll add like 3 to 5 parts per thousand of salt, as well as their anesthetic and their oxygen, just to help them along. Because fairly traumatic experience, being thrown in a bag or being thrown in a transport bin and being sloshed around for a couple of 100 kilometers down the Pacific Highway. Geez, our roads aren't that good, So yeah, salt helps. So yeah, not really a tonic. It's sort of a mild irritant to the skin, but it's a negative positive, I suppose. It's interesting to learn how that actually works when you figure it, when you learn that. So it's not about like salt being in the slime. It's about the slime actually making more slime to help the fish, as well as reduce that osmotic gradient, to reduce the amount of cortisol production, increase the amount of ATP, and reduce the stress and reduce the cortisol levels, which obviously then doesn't have as much impact on the immune system, because excess cortisol levels affect the immune system, and that's when they get sick. Sulfur transport stress, let's not go into that again. We just went through that. Okay, so specific salt tolerances. So generally speaking, for most freshwater fish, and I will preface this by saying I'm not talking about, wild caught fish. I'm not talking about things that you're going to pay thousands of dollars for. If you're going to go and buy something like an arowana or a giant gourami or something like that, you're going to have to know how to treat their water chemistry. And if you don't, you probably shouldn't be buying the fish. Okay. So yes, this is for information purposes, obviously, but know your species, do your research, and go slow. You can put more in. It's very hard to take it out without doing the water change. All right, but it's very easy to correct with the water change, which is fantastic. Okay, so 0.5 grams of salt or sodium chloride per liter of water, generally speaking, is a great place to start. If you're wanting to add salt to your aquarium for any reason to reduce osmotic pressure, just for healthier fish and things like that, 0.5 gram of salt per liter of water is great. We all know how many liters our tanks are, length, width, height, water level, substrate level. We all know how to work that out. Work out how many kilos of live rock. You can work it out. 0.5 grams of salt per liter. I'm talking about freshwater here. Okay. Now, generally speaking, you can anywhere between 0.5 and 1 gram per liter is generally the sweet spot to reduce osmotic stress. It thickens the slime coat, helps the biofilter and the plants, right, and helps with that ATP pump, right, and reducing cortisol levels and all that kind of thing. Okay, so 2 grams per liter. All right, this is where I used to sort of go with most of my freshwater fish, yes, and discus. Okay, most of my freshwater fish, whether I'm keeping them here, whether I was keeping them when I was doing, when I was working in retail, at Hunter Pets, 2 grams per liter, maybe for 3 or 4 days before a water change, just as a treatment. Okay, just as a preventative. It helps with mild issues. It just reduces the osmotic pressure and helps with their immune recovery and things after transport. And sometimes these fish have been in there for more than 24 hours, so we don't want to, want to help them out as much as possible. Now, generally speaking, above that, 3 to 5 parts per thousand is fairly aggressive treatment if you don't know what you're doing and you don't know the tolerances of your species. Okay, as I said, in a lot of freshwater holding systems, very common level, right? But you wouldn't go adding this 3 to 5 parts per thousand straight up with like cardinal tetras or anything like that. Go slow, add them 1 part per thousand at a time and things like that, unless you know your fish can handle it. And this all comes with experience as well. Now, golden perch fingerlings, bathing them for 24 to 48 hours in 15 part per thousand salt. They love it. No worries at all. As we know, guppies go into salt water very, very easily as well. Not guppies, mollies, things like that. Those species that transfer from saltwater to freshwater as well. So that's sort of your gradient. Okay. Having said that, I've been to quarantine-approved premises that are importing discus, and they're pouring like a kilo of salt, like a kilo jug, a 1 liter jug of sodium chloride into a 250 liter discus tank. And the buggers go down and turn on their side and they scrub and lie in the pile of salt as it's dissolving on the bottom of the bloody tank. Now, if they didn't like it, they wouldn't be in there like kids in a ball pit, would they? That's a very common misconception that, you're not going to go doing this with wild caught discus. You're not going to go doing this with champion bloodline discus that you don't know how much salt they can handle or anything like that. These were imported, multiple generation down the track, tank hardened, very healthy fish, right? But they loved the salt. Common misconception. So if that gives you an idea. So we were talking about all the different species and stuff. There's no need to go on that again. We've been over magnesium and hexamita. Just a few numbers for you. So in the feed, 3% of the feed weight for 3 days led to a lowered parasite load and to almost undetectable levels, and that was in the rainbow trout study. Edward J. Noga in Fish Disease Diagnosis and Treatment, one of the very, very, very well-known disease books, documents treating hexamida with magnesium sulfate. If you've got the book, go look it up. So magnesium has a laxative effect. We've been in that. In water use, again, follow your 0.5 to 1 gram per liter and things like that. But it depends on your fish. But magnesium, as I said, is going to be separate to sodium. Okay, when you're dosing, just as is calcium and potassium, because salt we're sort of treating as a separate entity. Okay. Sodium chloride, the salt, NaCl, I'm talking about. So, this is my one big bugbear. Everyone in the aquarium industry talks about using a TDS meter. I'm going to say it one final time. TDS meters aren't worth the plastic that they're made with in regards to an aquarium or an aquaculture system. They have varying conversion factors and varying different calibration solutions that you need to use depending on your application. One, there is no standard for those calibration solutions in aquaculture aquariums to tell you which one to use and calibrate to, because they all have different compositions. And secondly, there's no one that tells you what conversion factor to use. So anywhere between 0.4 and 0.7, you could have a difference of 30% in your parts per million reading. That's not accurate to me. And I have not met one person that uses a TDS meter that I've asked them, what's your conversion setting? Conversion setting? What calibration solution are you using? I don't know, the Broly one, There's no information out there about this, but TDS is used and is converted, and there's multiple different conversion factors. Usually they come with the standard, but sometimes people muck around and just change it, and you don't know when one person's recommending a TDS, what conversion factor they're using. Okay. Now, seawater salinity has one conversion factor because seawater is relatively the same across the world. So they just use one conversion factor, and that's what we're going to use to work out things in freshwater. Okay. So to give you an idea, a conductivity level of 200 US per square centimeter is 100 parts per million at a 0.5 conversion factor, 140 parts per million at a 0.7 conversion factor. 40 parts per million difference. That's only on 100 parts per million. Conductivity tests a shitload of ions, which we'll go into in a sec. All right, that's a big difference. No one wanting to be accurate about their water quality would accept that as an appropriate, resolution factor. 40 parts per million, that's 40%. Wow. So again, no standardized conversion factor. So the thing with salinity is it's got one conversion factor. TDS and salinity and specific conductance, but we're not going to get into that because it's just another form of conductivity. Salinity and TDS are calculated from conductivity. Conductivity is the raw reading. Conductivity is measured and measures every single ion in the water that will conduct an electrical charge. Badger, you're right. Going from saltwater to freshwater is easy. Going from freshwater to saltwater is friggin' hard because of the osmotic gradient. It's much easier to go down than it is up because of the concentration of salts and minerals in the blood, right? Sawfish are urohaline as well. I don't know why I didn't ask you. You're like the expert on it. I mean, Lyle's not here, otherwise I'd ask him. Visibly look dehydrated when converting them up in salinity if you move too fast. There you go, desiccation. There you go. Fantastic information, Badger. Thank you for that little bit of info. So, conductivity is the raw reading. So why not measuring conductivity and then just convert it? All right. I have a table that converts conductivity to salinity in parts per thousand and also a corresponding specific gravity reading. Now, because we know salt water is only one conversion factor. We can use that as the basis. We can divide parts per thousand by parts per million, and you can get your idea of what sort of grams per liter in parts per million that's going to be. All right, and how to work out the differences in salt and mineral concentration. All right. Just don't use the TDS meter. If you must use a salinity meter, only use it in saltwater environments because it's only one conversion factor. If you're using it in freshwater, just get a conductivity meter. So all ions contribute differently to the charge that affects your conductivity probe. All right. You've got multivalent ions and you've got singular charge, monovalent ions, right? So, and then you've got positive and negatively charged ions as well. So positively charged ions are sodium, potassium, calcium, magnesium. They've all got a plus after them, as we know. Ammonium will show up. Hydrogen, H+, so the acidity or alkalinity of the water, which is, the hydrogen ions floating around after we liberate, calcium and HCO3 and all that kind of stuff. Iron, manganese, copper, and zinc. Negatively charged ions, chloride, sulfate, bicarbonate, carbonate, nitrate, nitrite, phosphate, and hydroxides, and alkalinity, right? So you can see that all of the stuff that's floating around in the water that conducts an electrical charge is going to contribute to conductivity. So by testing conductivity, you will test everything that's in your water. All right? If you haven't added any sodium chloride to that, you now have a baseline. The only other more accurate baseline you will get is if you get an ICP test done, preferably from Triton. So you got your base water line test. Now you know that that's your basis for conductivity. And if you want to add sodium chloride, you've got a table and a conversion factor from salinity, salt water, back to conductivity that you can work out how many grams per liter of sodium chloride you're going to be adding, which means that if you do a 50% water change and you've added 5 parts per thousand of it and you're not sure what you're adding back in, just test your conductivity and work it out from there. Because if you've got your ICP test, you've got your baseline. If you've got your GH test or your conductivity, everything else that's in your water, you can obviously work out what your alkalinity is and what your nitrate levels are and stuff like that. I mean, but each ion contributes a different amount of conductivity to the conductivity reading as well. So just because nitrate interacts with it doesn't mean that it'll have as much impact as the same amount of ions as calcium, for example, or sodium. All right. So conductivity probe won't detect dissolved gases, oxygen, CO2, nitrogen, blah, blah, blah. Non-ionic organics. So sugars, alcohols, dissolved organic carbons, urea, things like that. Uncharged molecules like silica or boron. Suspended solids like particles, floating algae, uneaten food, all that kind of stuff. Or any other things in the water, like, other organics or ions or anything that don't conduct an electrical charge. Conductivity, conducting electrical, think about that. But having said that, two conductivity readings of exactly the same can have very, very, very different ionic concentration and makeups. So, well, not ionic concentration. Well, yes, depending on the ion, concentration of those ions, right? So using this chart and using the mineral balance blog, I will expand on that a little bit. You can use salt water or salinity as a baseline to adjust your salt water independently of GH. All right. We can work out numbers later. We don't need to work out what it all is in regards to millisiemens and microsiemens levels. I've got a table for that. But if you say, oh yeah, I run about 1 part per million, 1 part per thousand salt in my water, in my aquarium, it should measure about 490 US per square centimeter, but it won't, because you've got calcium and magnesium in there, on top of sodium chloride, right? So it's a good idea to know what your conductivity is going in before you start adding extra conductivity to it. Yeah. So because salt water is so stable, we can use that as a baseline. Not in regards to like the amount to add or anything like that. It's just in ratio, it's in balance, and it's standardized. It doesn't really change. Maybe within 1 to 3% or something like that. Bugger all. 9/10 of bugger all, in fact. So, what that allows you to do is it allows you to get your baseline reading. So whether you do that with an ICP or not, and an ICP is a good idea to figure out whether you've got calcium, magnesium, and potassium in the right levels in your fresh water. And then you can use conductivity to adjust. Now, there was actually a feature in, I think it was like the G6 canister filter or something like that from Fluval years ago, where they had a conductivity probe in there that they would say, if your conductivity starts to go up over time, it's an indication that your nitrate levels are increasing. And it is, because nitrate is an electrical conducting ion. It's in the list. So you can use that. But, you need to take into account all your different levels. Now, I will go into one thing. I want to just confirm for everyone right now what the difference is between alkalinity or carbonate hardness and general hardness. Okay. A lot of people get this mixed up. I want to settle it once and for all. Okay. Carbonate hardness or alkalinity is what gets eaten up by your bacteria. It is temporary, or what is called temporary hardness, because it constantly drops much faster than general hardness does. Okay. General hardness is called somewhat permanent hardness, because if you were to dissolve, well, if you evaporate all your water, you'll get every bit of salt and mineral out of it. Right. But general hardness is more permanent, sticks around for a lot longer, and it will build up, right, if you've got excesses, right? Alkalinity will not. Alkalinity gets biologically assimilated by a variety of different biological actions, predominantly your biofilter, nitrifying bacteria. So, carbonate hardness or alkalinity, German DKH, okay, is temporary hardness. Say it again, it's temporary hardness. People get them confused all the time. And general hardness is what they call permanent hardness, because it's like that's what precipitates onto your glass and scaling and things like that. Okay, much harder to get rid of. Right. So, but your general hardness test kit is only testing calcium and magnesium. It's not testing sodium. It's not testing potassium. It's not testing anything else below that either. All right. So, knowing this, you can get a baseline before you start adding sodium chloride and work out what the conductivity level of all your ions are in your water. Okay. So you don't go in there and you go, oh, I must already add salt in there because it's already a 490 US when you haven't added any salt. No, you need to know what your baseline is. You need to know what your source water is. This is why marine aquarists use RO water, because it's got nothing in it. So they know everything they're adding because they add their synthetic seawater, or, they're adding it to a marine system for top up, and they don't want to add any salts and minerals to it. They only want to replace the water that evaporates, because when water evaporates, it takes the H2O and it leaves all the rest of the shit behind, salts and minerals included, and everything else. Okay, so they only want to replace pure water. Generally speaking, in fresh water, we don't do that, because we either dechlorinate our water, or better yet, we carbon filter it. It hasn't got very much in it to begin with, unless you live in Melbourne and your water is liquid cement. Is that Melbourne or Adelaide? Either way, it's not great. So when before we're adding salt, we're checking your baseline. Now, conductivity will tell you everything that is in your water, but it won't tell you the levels of those things and what that is in your water. You need to get an ICP test done. No, a general hardness test kit will not tell you. Okay, if you're that fussy about it, get an ICP test done. If not, the baseline test will be enough for you to figure it all out. Yep, there you go. RO water in a planted tank, because he's adding all the rest of the salts and minerals, general hardness. I will guarantee, being reservoir aquatics, that they add calcium, magnesium, potassium either separately or they blend their own and add them at the ratios that they need them. Okay, and RO water allows them to be exactly, and this is how you maintain stability, right? So by getting a conductivity reading, it's the best thing other than getting an ICP reading to figure out exactly what's in there. And then you know that if you're going to increase the salinity and the conductivity with sodium chloride, what that level will be in relation to your baseline, right? Then you also know that if your baseline conductivity is really, really high and you need to get it lower, you can cut it with RO water. Or you can cut it back with RO water and then add a supplement to it. If you're going to be doing that, though, just get RO water and get a conditioning salt that's got everything in it. All right, but you get my point. Then, once you've got that, you just need to keep records of when you add salt, what water change you do, so you can calculate how much of the salt and mineral is taken out, because it's not just going to take out the sodium, it's going to take out the water that's got the sodium and the already existing calcium and magnesium, and if you have potassium or whatever in there, right? And you can calculate and you can work out how much salt to add. It stops your system from bouncing up and down all the time, you know. And then if you want to know exactly how much is in there, again, I sound like a broken record, but go to Triton, get an ICP test done. I honestly should buy shares in Triton. Actually, I mention that often. That is pretty much it for maintaining salt and mineral concentration using conductivity in freshwater. Okay. Now, obviously, general hardness and sodium chloride are not the same. Sodium chloride does not contribute to general hardness, but it will contribute to conductivity. Okay. Sodium chloride adds sodium chloride, but it does not affect GH at all, so you're not going to see the change on a GH test kit. Carbonate hardness measures the carbonate and bicarbonates, and the way that works with a test kit is how I was talking about the GH test kit. Well, this is an acidifying titrated endpoint, where it's actually acidifying and acidifying all of the base ions in there, the carbons, bicarbonates, borates to a certain extent, and acidifying it. And that indicator on there is telling you when it's a certain pH, which is affected by the alkalinity, which is being acidified by the reagent that you're putting in. But carbonate hardness will contribute to conductivity somewhat. Okay. Don't know how much, because each ion contributes a different amount of electrical conductivity per molecule, right? But they will contribute. So if you're running your carbonate hardness at 20 or 30, bugger all, don't worry about it. If you're running it at 150 to 200, like we would in an aquaculture system or a marine system, you know, it's worth considering with an electrical conductivity probe. And a lot of freshwater systems in aquaculture will monitor electrical conductivity for this exactly, for varying reasons, this being one of them, because physiological and dietary requirements, you'll get bent spines, you'll get blindness, you'll get caved in guts, all sorts of stuff. We're talking about, over 100 kilos of fish per 1,000 liters of water. It's, orders of magnitude more heavily stocked than an aquarium. So, water concentration matters. So as we said, you can manipulate NaCl or salt independently of GH. So if you've got a GH test kit or you've got an ICP and you've got your conductivity baseline reading, you can work out what your conductivity will go up to. So you can work out after doing water changes when you get back to your baseline. Right? So yes, conductivity measure, total picture. Don't use a TDS monitor, please. If you use a TDS monitor, I will find you. I will hunt you down like a dog. I will smash the TDS meter in front of you, and I will make you sit down and read this transcript from front to back 15 times and then write it out for me. Stop using TDS meters or you will make me cry. Stop. So again, the conductivity level tells you what the conductivity level is. It doesn't tell you what's in it. So ideally, if you took a conductivity reading from your water and you got an ICP test, you could work out what that conductivity reading generally represents on an ICP test, and you can just send away to get that done regularly. if you want. Okay. Having said that, you could try and get the information from your water supply, but Water New South Wales is notoriously hopeless at, well, record keeping for one. But they won't be able to tell you how much calcium, magnesium, and stuff's in there. That's honestly the stuff they should be doing. In America, you can get an entire breakdown. It's required. It's an entire breakdown. In New South Wales and in Australia, good luck to you. It's like pulling teeth. No, sorry, it's not like pulling teeth. It's like pulling teeth without anesthetic with a pair of rusty pliers out of a heavily and severely ingrown toenail. That's how painful it is. So just get an ICP test. So, yep, conductivity readings. It'll tell you how much is in there. It won't tell you exactly what of which. But you can work it out. We've been through all of that, so let's not go over it. Okay, so we've been through the saltwater, freshwater species, the ones that are jumping around all over the place, how they do it, and at a cellular level, what happens. We've talked about how some species characteristically can handle salt when everyone would assume that they can't. And I'm telling you, I saw it firsthand on multiple occasions. I even did it to our discus in the store. All right. I don't know how many people have done this before, but yeah, it's amazing to see bread and butter plate size adult breeding pair discus go from full fresh water, what I'm saying, full fresh water, with no salt in it, right? And coming along in a 250 litre tank, dropping a kilo of it, like there's a pile of it like that in the bottom of the bloody tank, right? And you can see it dissolve, and you can see the streamers coming off it like you always do if you put a lot of salt in the tank. And the buggers are going down and lying in it, scrubbing themselves in it, getting into it. It's amazing. It's amazing to see. So, do it carefully, but, you need experience. I didn't learn all this overnight. I've been in this industry for over 20 years. So, this is what this stream is for. Plants need some sodium and chloride too. In hydroponic systems, it's actually very common to add a small percentage of fresh salt water, seawater into the system, or sea minerals or sea salts into the system for all the aforementioned reasons. Or toxicity versus concentration. Know your species, know their limits, and adjust accordingly, slowly. We've been over all the deficiencies. We don't need to go over that again. This is an hour and a half already. Wow, guys, we've actually got through that in actually good time. An hour and a half. I think I may have skipped over some stuff or mentioned a few things multiple times. But I think we did fairly well. Just a reminder, the giveaway, I have not forgotten. The giveaway is 500 ml bottles of our product Cataplex, which is our Indian almond leaf micronized complex. Now, to give you an idea about that, it's not just another tea. Okay, I don't heat this at all. It's not heated. There's no degradation. There's nothing. These are 100% organic, hand-collected Australian Indian almond leaves from areas that are known to not contain pesticides. It is 100% organic. Okay, it retains all the natural microorganisms and everything like that. And then on top of that, from Microbe Market, from the strain library that we've got, we choose a variety of different organisms that go into breaking down lignin, cellulose, and all those kind of things. We go through an aerobic phase and an anaerobic phase. So not only do we get aerobic production of beneficial microorganisms that are also very, very heavily involved in probiotic action as well. Then we get a anaerobic phase, which acidifies the product, fermenting it and preserving it naturally. There's a small amount of salt in there for that fermentation, obviously. So what you get is a liquid suspension at the end, which is micronized leaf particles. The whole leaf is in there. I don't strain it out. You are getting all of the solids from it. This is a fantastic flocculant and clarifier. You can't really overdose it, and you get, you're not going to go throw a heap in at once, but you can gradually build it up. And you get not only the particles that go through, which clarify your water, sink to the bottom with organics, that adds microparticles for biofilm formation. And it's already got biofilm formed on it because I added all those microbes before. It is literally one of a kind. I see people soaking and everything like that. No one does it in the way I do it. And it is an incredibly powerful and potent product. As I said, you get all the solids in there. As with Indian almond leaf, the dose is as you would want, but there are dosing rate instructions on it. So 500 ml Cataplex. As I said, it's about a 3 or 4 week process. This isn't just like tea it, mix it up in a day, put it in a washing machine with some boiling water and some bloody peat moss, and some sphagnum peat moss, and spin the bejesus out of it for half an hour and then bottle the water. It's all dated, aerobic phase versus anaerobic phase, the amount of days under airlock, everything. Okay, so it's like a soy sauce, Enough about Cataplex. Microplex, for anyone that's been looking into probiotics and things like that, Anya and the guys at Gallery Aquatic have been giving me an absolutely fantastic rap with the NComp. I can't thank them enough. They've had fantastic results treating dinos with it. NComp is the nitrifying product. It does aerobic nitrogen removal. So in the presence of oxygen, you don't have to have an anaerobic area, and it uses predominantly endogenous sources of organic carbon. So the crap that's in your tank, it eats to fuel that process. Okay. Also outcompetes dinoflagellates, has a lot of different probiotic strains in there for support. The microbial interactions in biofilms for probiotics and nitrifiers and archaea and things like that is amazing. I could bore you for hours. But Microplex, I'm giving away 5 50-gram samples of Microplex, and you might be thinking I'm a bit of a cheap bastard, but for anyone that hasn't looked into Microplex is 1 gram to 350 to 500 liters of water. And at that dose, it gives over 100,000 CFU per gram dose rate. It's the strongest probiotic powder on the market, and it has 20 different strains of probiotics in it. Everything from marine yeasts to photosynthetic bacteria, bacillus strains, strains that are specifically antagonistic to things like Vibrio and other disease-causing organisms, Bacillus subtilis, Bacillus licheniformis. There's specific, they're 2 big ones that are really good at competitive exclusion and reducing organic mold and organic deposits and things like that. There's even Bacillus it sounds like mucus, mucilagidosis. I'm terrible at pronunciation. It's a remineralizer. It will remineralize calcium and magnesium and potassium that is locked up in mold and in different mineral deposits, and it'll actually eat it up like it eats rock and remineralizes things. So it can remineralize those minerals back into the water column for osmosis for your fish or for your plants, or to feed to your plant root zones or anything like that. So it's an all-in-one mix. It's used for, you don't want to do 3 different things. You want something that's just a broad spectrum, and it's going to put very efficient strains in that are very pure, but also of a good variety, so you don't get single strain dominating in your tanks and things like that. And you want to keep everything sort of ticking along. Variety is the spice of life when it comes to microbes. Okay, biofilms are incredibly diverse communities. Yeah, I do have other products so I have a product called Sub 6, which is specifically for phytoplankton bloom support. And what I mean by that is in aquaculture applications, some people in aquariums might, how you have ponds and you breed algae in there and, for your fish, for green water and things. Well, in an aquaculture pond, because we've got tons and tons and tons of adult fish and we're only aerating it, right? We don't have a biofilter. We need the algae to filter the water. And we want to break down the sludge in the bottom because we don't want that building up, because then we get disease-causing organisms and we get it sucking oxygen out of the water, oxygen that would go to the fish for growth, right? So we want to reduce the sludge in the pond and remineralize all the nitrogen and phosphorus that's locked up in that sludge back into the water column. So the plants, the algae, the unicellular, the green water can use it. But when we're remineralizing, we don't want anything that's going to denitrify, anything that's going to take care of phosphate or anything like that, okay? Because we want the algae to be able to use it. So the blend contains specifically not denitrifying strains and things that aren't going to actively scavenge phosphate, plus the mineral scavenger that we've got in there and a couple of other disease-reducing bacteria and things like that for stability of the system. And that has a different strain selection in it without all the other stuff that I have in Microplex. And, you know, microbe market, you can mix your own. You can mix a dietary supplement. You can mix, you know, I can guide you in it. There's a whole selection table. I have a very, very in-depth selection table that I use in, you know, call me up over the phone. We can have a yarn. And generally speaking, if you're buying 250 grams of it, it's no more expensive than Microplex or Sub-6, generally speaking. Because, you know, at 10 grams, weighing out 10 grams for an individual strain, it's expensive. But when I start mixing it together and things like that and start, you know, it becomes a lot more economical. So generally speaking, a custom mix won't cost you any more. And I can guide you in that if that's something that you want to get into. As well as that, people that are doing OEM mixes, any manufacturers out there that want some ideas on, you know, aquaponics specific stuff, plant specific stuff, you know, you want to develop your own bacterial blend, we can do them. Some we only have in liquid, some we have in powder that we can turn into liquid by brewing it and inoculating it. So yeah, any manufacturers out there that want to put a bacterial blend just for them to their name and they want help formulating it and then want to provide it as an unlabeled plain package OEM product with all the information on it so they can put it on their own label and shit like that with the backup support, you know, with the knowledge, give me a call. Happy to help. And I have one Reese Scarab air pump, which is my 18 litre a minute adjustable air pumps. I originally bought these for ozone generators, for supplying my ozone generators, my Poseidon ozone generators, and the smaller stuff up to about 5 to 10 litres a minute, because the majority of that is air driven. So it's either with the desiccant dryer or, yes, with the desiccant dryer. So you need to positively feed it in, and then you just feed it into the suction line of your skimmer, and then any extra your skimmer pump draws in, right? And as long as you got your skimmer, your air suction line connected up to your skimmer cup, it won't vent into the atmosphere. Or you can have it so that if the power goes out, it turns off, or you should always have it controlled by an AWP monitor or things like that. I'm getting off topic. The reason I bought them was because they're adjustable. They have a very high pressure outlet capability, more than other pumps. And they're adjustable, and they are quiet and so well built. So total value is over about $600. Hey, so yeah, everyone that's engaged tonight, everyone that is engaged with the posts leading up to, will have their name go into the draw. Thank you very much for being here. You will be drawn out, and I will let people know. These things will be posted to you free of charge. So just let me know. And I would be happy to include anything else you like at the same time with that, as long as it's not excessive and it doesn't go from one item to 47 items that are now going to cost me $300 to send. So yes. Okay. Yeah. Anyone that wants the transcript with my scribbles, I'm quite happy to give it to them. It doesn't really read like anything. It's just got info in it. It's just like summarized stuff of my blabbering shit dribbling. So if you want it, let me know. Send me an email. You can find my email on the website. It's info@btaqua.com.au or gb@btaqua.com.au is my personal address. If you would like to get in contact with me, you can call me. You can send me a message via the store. You can call me again. You could send me a letter. It might take some time. I don't have a fax machine because it isn't 1985. Options, yeah, talk to me if you want. Happy to. Does anyone have any questions at all from anything? Any comments? Anything that you want to talk about at all? Because I'm happy to hang around for another 15, 20 minutes or whatever if anyone has any any questions they'd like to ask. God, that tea is horribly cold. Well, unless someone's typing at the moment, it doesn't look like anyone has any questions. If anyone does, no worries, Anya. Thank you very much. If anyone has any questions, follow-ups afterwards, wants any information, wants the transcript, wants to talk shop, wants to talk about anything that I've talked about, wants to talk about anything at all. I like to solve problems. Death rates, standard operating procedures, biosecurity, product selection, anything like that. Like, just give me a call. I mean, most of the time, I don't sell anything. As long as you get the information that you need, a well-educated customer is a better customer. Okay, whether that's a store owner on a wholesale relationship or whether that's a retailer on a retail relationship with their customer, a well-educated customer is a good customer because they're going to be successful. And I can do these streams all the live long, but it's kind of the store owners and our responsibility as industry professionals to relay this information to teach new people coming into the hobby and teach people that might not know this information, because this information isn't available everywhere. Like, it's not available really not put together, not comprehensive, fundamental. Yes, by all means, Zoe, the sludge busting for phyto works in freshwater and saltwater. I know a lot of people who actually do pure phytocultures that will maintain a microbial level in there because the co-culture is actually what keeps it stable. If you're doing green water outside and it's not like pure culture or anything like that, yes, it's fantastic. Would you like me to send you some? Because I can. That offer goes out to any stores or anything like that would like to either try my pre-packaged product or like Microplex, Cataplex, the Indian Armour Leaf stuff, Encomp, which will soon be renamed with a new label. I've got my new bottles. And obviously everyone, well, if you've seen the Microplex and Cataplex labels, they're quite smart looking. I'm going to be putting barcodes on them and stuff for stores and stuff like that too. So that's a little bit of an upgrade. I'm getting there. But yes, anyone that wants help, just give us a call. Quite happy to help. Other than that, if no one has any other questions, I'm absolutely busting for a cigarette. I know it's terrible to say, but vices will be vices. Thank you everyone for coming along. I hope this is the first of many. Maybe the next one won't be so information dense and will just be me dribbling a little bit more. Got some interesting stuff coming up. UVs there's been some progression with those as well, with the new Uvionic UV line. If stores are wondering, the Uvionic UV line has very attractive trade pricing for resellers. And with the new SKM BTA protein skimmers, the recirculating protein skimmers that are coming in that will be landing in the next 2-3-ish weeks, as well as the Uvionic sterilizers and a couple of other BTA exclusive products that are BTA branded, I am looking for like-minded technical-minded expert stores that would like to join the distribution network for these higher end, more technical, higher quality, higher engineered products. Just like LED lighting, there needs to be a level of expertise, and it's my job to educate everyone on that. If you are a store that likes the higher end stuff, you do a lot of different installs, customer servicing, you have a lot of high end stuff where you sell UVs, high end skimmers, things like that. You want the technical. Essentially, my ethos is aquaculture engineering miniaturized, right? So industry standard engineering, solving all the problems that things have had over the last 20 years that I've wanted to fix but haven't been able to, and providing them at a very good price point for stores that can resell them, and also give you guys the backup knowledge that you need to sell them effectively. Again, if I can educate you, your sales and your success will be a lot better as well. So if that is something that you're interested in, I'm quite happy to provide staff training. I'd be well and truly thrilled if you would like to even put them up on your website or take them on as a product range or anything like that. Having said that, you don't even have to. It can just be you're looking for a UV or a protein skimmer or ozone or something. Give me a call. I can even drop ship them to your customers. I'm not fussy. Okay, I'm not fussy. You want to claim the sale with your customer, claim the sale. I'm not going to take it. It's not. I don't want my bread, my cake, and eat it too. We're here to support you guys, you retailers, and all customers and even end users with knowledge and product and experience and support. So if there's anything, give me a call. That's enough of my business spieling. Good night, everyone. Have a wonderful evening. If there's any ideas as for a live stream that you'd like to do next, that you'd like to hear a subject on, send me an email, put a post up in the future group, Paul's group, and I'll see what I can do. Let's get some conversation going. The group's been far too quiet. Yeah, I think we should get some conversation going and some interaction. One final thing, if you are not a member of the PIAA, please join. The PIAA is protecting us from essentially not having an industry. Okay. The time to band together is now. We get nowhere unless we work together. And the PIAA is doing that. Now, I've said it once and I'll say it again. Anthony Ramsey has turned that thing around, and he has done something with that I didn't think was possible. And look at the staff he's got now. And anyone that knows mine and Anthony's relationship will know that we didn't see eye to eye for a lot of years, and I have never been happier to be wrong. Anthony has absolutely hit that out of the ballpark, as has every other single member of the PIAA board. Okay, you can trust that they've got your back. I'm a member of the PIAA. I use their services when I needed some legal advice as well. And the support that you get from other members in the PIAA as part of camaraderie is invaluable. Okay, mistletoe on a tree, it doesn't, it's a parasite. It doesn't live in conjunction with them. The more anguish, the more fighting we have with each other, the more mistletoe that gets added to the tree. Do you know what happens? They don't coexist. It kills the tree. That's what, this, division between everyone is causing. We have no time to kill the tree. We all need the tree. Don't be the mistletoe. Let's work together. If you're having problems with membership, if you're having problems with business and stuff, ring us. We're all happy to help. I am more happy to provide all of my time as much as possible to anyone that wants to talk about the PIAA. And as someone that has been very vocally against Anthony Ramsey in the past, I can tell you right now again, I've never been happy to be wrong, and I will tell you exactly why. If you want the no frills, unfiltered version and you want to talk some logical conversation, I would be more than happy to give you give you the time if you wanted to call me. Okay. Support the PIAA. Anthony and the PIAA are flat out, Anthony especially. So if he doesn't get back to you, just give him a sec. He's got some stuff on. He's dealing with some things. He's busy. He's got a business to run as well as doing the PIAA, mind you. He's got a store, if you didn't know, which most people do. Yeah, support your PIAA. Give Anthony Ramsey a high five next time you see him. Buy him a beer. Yes, I am looking at the chat. Coral Vids. I don't know who Coral Vids is. Thank you for the moustache comment. If you haven't figured out, I'm also quite loud. So, yes. Yeah, and Anthony does so much behind the scenes, and some stuff that he can't talk about. Talking with lobbyists, talking with the PIAA board as to the different parts, the grooming and, all these things, talking to state members, talking to members of the lobbyist groups that would see us crash and burn. They would be happy if we never sold a fish again, let alone a dog or a pet or a bird or a mouse or a rabbit, Yeah, the PIAA is doing great work. Constantly getting these new fish in. They're constantly sending out, bulletins and help. Honestly, as an industry, I think it's a bit embarrassing that the membership pool is so low in the PIAA. So, to put it bluntly, if you're not a member of the PIAA and you're in this industry, the PIAA is doing work for you, whether it's regardless or not, and it's the least you could do to pull your socks up and become a member, because it's not expensive and the support and the value is there, especially when you don't see it, like Paul just said, because sometimes it can draw bad attention, sometimes it lives out, sometimes it frustrates people when you're having to talk to things like Peter and other lobbyist groups and things like that, okay? It's keeping the industry alive, and the least we can do is support it. So, yeah, go and become a member. Go now, right now. Close the live stream. Bye-bye. Go now. PIAA, into Google. Go and sign up for a membership if you're not already. Do it now. And then I promise next time I see you, I'll give you a high five and a hug, and I'll let you wear my hat. Apart from that, ta-ta. Nothing further to report. Cheers, guys. See you later.